What's the vector, Victor? Okay, so today we're going to talk about vectors. And I'm going to start out with a very simple thought experiment. So you are in an open field, and you know that somewhere in this field is buried treasure. And there is a pirate who is knowledgeable about where that treasure is. And you are able to ask that pirate only two questions for two simple pieces of information in order to find where to dig and get rich. And I would submit that the first question you might ask that pirate is, in what direction is the treasure buried? And so the pirate might point in a specific direction. And now you have a good idea that the treasure could be here or here or here or here, but you don't know exactly how far the treasure is. And so that is your next question. Okay. Which direction or which way to the treasure is your first question. And your second is, how far is it? And so the pirate tells you it's 10 paces, and you count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. X marks the spot. You dig and you get extremely rich. In math, and vectors are used in math and science, we say that a vector is fully described by the direction and the magnitude. All right, so direction is the question, which way? And the magnitude is the question, how far? In geometry, we mostly talk about direction in terms of angle. And we talk about magnitude in terms of distance between points. Okay, how far? Okay, a vector has an initial point, a terminal point. Also has an arrow, and this arrow indicates the direction. So it looks a lot like array, but be careful, it's not array. So don't call a vector array. It's a very different concept in mathematics. We can, for example, call this vector v, right? It's just like the symbol for array, but with half the arrow. Next, we're going to talk about the component form of a vector. Is written as delta x, delta y. If I were to draw a vector here, we could break that down vertical and horizontal components. Okay, and this would be my delta x, and this would be my delta y. All right, so direction is indicated by the sign. So for example, down would be a negative change. Up would be a positive change. To the right would be a positive change. To the left would be a negative change of my delta x. So we can say that vector u equals -3, +4. Okay, this is the component form of a vector. And so if we were going to draw that vector, we could put our initial point at 0, 0, make this easy, right? And then we're going to go to the left 3 and up 4. And the vector would point in that direction, right? And then if we break it down into our component parts, our delta x would be -3, right? Negative because we're going left. And our delta y would be +4 because we're going up. So the magnitude of vector u which we write like we put it in absolute value, would equal, using distance between points formula or Pythagorean theorem, we would take our delta x squared plus our delta y squared. And that gives us, we should recognize this as a 3, 4, 5 triangle, but I'll do the work anyway. So that gives us the square root of 9 plus 16, which is the square root of 25, which is simply 5 units, right? So this vector has a length of 5 units, the distance between the initial point and the terminal point. Finding the angle is beyond the scope of this course, but we can certainly find the slope, which is an indication of direction. And so my slope is simply delta y over delta x. Notice that this is my delta x and my delta y. So I simply substitute in, got to keep the signs. So I get 4 over -3, or simply -4/3 as my slope. Finally, let's do a transformation using a vector. So we're going to translate triangle ABC along vector V. And vector V, we're going to write in component notation, is -4 and +5. Now we're going to take this vector, and from each of our vertices, we're going to draw that vector and find our A prime, B prime, and C prime. So starting at point A, if I go 4 to the left and 5 up, that puts me right up here. So that's going to be my A prime. I can go ahead and draw, and I'm going to draw it with a dashed line. This is my vector. But all 3 of these vectors should be parallel, and they should be the same length, right? The same direction and the same magnitude. And because it's a rigid transformation, the shape does not change, the size does not change. And that's how we use the vector to complete a transformation. Let me color this in so you can see. This is my pre-image, and this is my image. And how has this translated? It's translated along this vector. Notice also I can find the magnitude, right? So the magnitude is simply 4 squared is 16, and 5 squared is 25. So if I add those together, I get the square root of 41 units would be my magnitude. And I could also find my slope. My slope is just simply my delta y over delta x. So it's -5/4. Done, right? So what's the vector, Victor? The vector is direction and magnitude. And we can write vectors in vector component form, and that helps us to use them to complete translations on a coordinate plane. I hope this was helpful, and remember that practice makes better.
I see math in everything.
I see math in everything. There we go.